All right, and finally, we're going to look at 1 for 0 order. Now remember, in the last video, I said you could come across questions dealing with second, first, or 0 order that ask for different things, right? One could ask for K, one could ask for T, one could ask for the initial concentration, one could ask for the final concentration, but all you need is those equations that you have, right? And all you need to do is just plug it in and you can work it, all right? So, I'm sorry, let me pull up the 0 order equations right here. All right, here we go. So, this question says, I'm taking it straight from the homework, the reaction A, arrow sign B plus C, all right, so that's not a real chemical equation, right? We just know it's just substituting random letters, is found to be 0 order. All right, so now that we know it's 0 order, we got to look back because this is a new formula that we haven't looked at, right? We've looked at first, we've looked at second, but we haven't seen 0 yet. So this is a new formula, all right? And whenever a question asks for 0 order, we have to use the 0 order formula. All right, so this one is the final concentration is equal to negative K times the time plus the initial concentration. This is pretty easy given the other ones we looked at, so I'm kind of glad. All right, now it says it's found to be 0 order, so we're going to use this equation, right? If it takes 430 seconds for a concentration of A to go from 0.5 m initially, all right, to 0.37 m, what is the rate constant for the reaction? All right, so if we read it again, we're going to see what it gives us and what it's asking for, all right? If it takes 430 seconds, all right, so it gave us the time right here, T. So we're going to go ahead and plug it in, just like we always do. All right, so T is 430. All right, 430 seconds, all right, just like that. Here we go. All right, let's keep reading. If it takes 430 seconds for a concentration of A to go from 0.5 initial value, all right, so it says initial value, 0.5 m, all right? So that means if it's the initial value, it's going to be the initial reactant, right? That makes sense. It tells us. It says initial value, meaning it's going to be the initial concentration. So we can go ahead and add, that's a plus sign, by the way, I'm sorry. We can go ahead and add our initial concentration, which it told us was 0.5, all right? Just like that. Now, if we keep reading, it says it goes from 0.5, which is the initial value, it tells us that, to 0.37 m. All right, now anytime it says the word to, or if it says goes from this to that, the second one, the one it's going to, is always going to be final, right? That makes sense. If it's going from A to B, B is always going to be the second one, right? B is always going to be the one in the future. Now remember, anything that's in the future is the final reactant, all right? So it says it's going from 0.5, the initial, to 0.37, all right? So the 0.37 has to be the final, all right? Now if you look at our equation, it says the final goes right here on the left side. This is an equal sign. So we're just going to put our 0.37 right here on the left, all right? Now it says, what is the rate constant for the reaction? Well, what is the rate constant? The rate constant is just K, right? So it's asking us to solve for K, all right? Now that we have our equation set up, we just do the simple math, all right? I'm going to subtract 0.5 from both sides. So over here I get negative 0.13, all right, is equal to negative K times 430, all right, just simple algebra. Now all we do to get K is divide both sides by 430, all right? So all I'm going to do is do 0.13. Oh, and by the way, since there's a negative on both sides, you can just go ahead and cancel these two out, all right? Now remember, in the equation, there is a negative sign here, all right? Just like the first one. There's not in the second one, okay? There's no negative here, but there is a negative in the first order and the 0 order. So just make sure to put that in, otherwise you'll get your answer wrong. All right, but since there's a negative on both sides here, we can just cancel it out. All right, so we're just going to take 0.13 in our calculator and divide it by 430. And we get 3.02 times 10 to the negative fourth as K. 3.02 times 10 to the negative fourth. And that's our answer. All right, so hopefully this helps Taylor. Yeah, good luck.